If I don't have a number, the limit does not exist. This specific one from either side does not exist. The limit from the left exists, the limit from the right exists. As long as they are not equal, the limit from either side does not exist. Now let's look at a few examples in the book. So convenient to have the book handy like that. Okay. So I don't need to do that. I just need this directly. Okay, so let's look at a couple of examples. Where are my graphs? Okay, let's just take a look at this one. What is the limit? Oops. What is the limit from either side of 4? Can anyone give us the limit from either side of 4?
4.
Excellent. Do you care that the function doesn't exist at that point?
No.
No. Very good. What is the limit from the left of 2?
No, does not exist.
The limit from the left of 2. You're way ahead of me. You're right, of course. 2. What is the limit from the right of 2?
2.
1. So the limit from the left of 2 is 3. The limit from the right of 2 is 1. And now final question, the limit from either side
Doesn't exist.
does not exist. It's not one number. So if it's not one number, then it does not exist. Excellent. Okay. What is the function value at 3? You have the obligation to stop me if you have questions. What is the function value at 3?
3.
Excellent. Do we all see it? The left limit, the function limit from the left of 3.
1.
Very good. From the right of 3.
4.
From either side of 3.
Does not exist.
Great job. Okay, so let's take a look at this one. This one is interesting. Let me ask a couple of questions. The limit from either side of 0. Either side of 0.
Doesn't exist.
Does not exist. Either side of 2.
2.
2. Either side of -3.
5.
5. I think it's 4. So, good. Excellent. So now let's look at here. This is 5. What is the limit from the right? From the right with higher values of 5. From the right of 5.
Say 3.
Perfect. This is an example of an oscillating limit. Up, down, up, 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 down, down, up, 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 up. So the left-hand side, the limit from the left of 5 is DNE. It doesn't stabilize. It does not approach a particular, it does not have a tendency. It has multiple tendencies. So the left limit here does not exist. The right limit is indeed 3. 1, 2, 3. Okay, now I want to talk about infinite limits. Okay. We have two things. We're only going to discuss one of them today. So infinite limits, and this is for later. I want you to understand the difference. Infinite limits and limits at infinity. These are not the same. Limits at infinity are not for today, but this means something like this. Limit as x approaches infinity of f of x. Or x approaches, not both at the same time. these are limits at infinity, when x approaches infinity or negative infinity, but this is for later. What we want to talk about right now is infinite limits. Okay, so few examples here. First function, a function that we have to have in our minds forever. Simple rational function, the simplest one is this. It doesn't touch here. Sorry, my marker sometimes, my hand, not the marker. It's not the marker's fault. Okay, so do we remember what this line represents for this function? Anyone?
Vertical asymptote.
Very good. X equals 0 is the VA, vertical asymptote. Good. So can anyone tell us the limit as x approaches 0 from the left of this function? And can anyone give us the limit as x approaches 0 from the right of this function? All you have to do is look at the graph. You know, that's why I graph. Say the first one is
Negative infinity.
very good. The other one is
Infinity.
very good. And now can you draw a conclusion about the limit as x approaches 0 simultaneously from either side of 1 over x?
Infinity is the limit, right?
Does not exist.
Right. So follow my hand. When x approaches 0 from either side, look at the function. What does the function do? Is that clear?
Yes.
Perfect. Now, here's one more example, and we'll go back to the book for some examples. Stop me if you have questions, please. I keep repeating myself, so now you know I'm not going to repeat that. So, limit as x approaches 2 from either side from this function f of x. What would you say?
Infinity.
Very good. Now, also I want to specify again. When we started talking about limits, we said the limit exists only if what I give you here is a number. Does this limit exist? Is infinity a number?
No,
No.
does not exist.
Right. So, but this is not a situation in which we can write D and E. But we know that still the limit does not exist. But we cannot write D and E here because both sides go in the same direction. But it's still D and E. We can write D and E only in this situation. If both sides are a positive infinity, I have to write positive infinity. If both sides are negative infinity, I have to write negative infinity. But since this is not a number, the limit does not exist. Back to another graph, okay? Can anyone identify the vertical asymptotes of this function? What are the vertical asymptotes of this function?
At 2.
Yes,
Yeah,
x equals 2, very good. Anything else?
-1.
X equals -1, not -1. Please remember, x equals -1, x equals 2, and?
X equals -3.
Brilliant, awesome. I would like to look at a couple of limits. So here's one. Limit of x plus 1 over x minus 5 as x approaches 5 from the right. Okay, so here's our first example. Of course, we are not going to graph of all functions ever to determine the limit. Oh, no, no. So we have this limit. We're asked to find the limit of this function when x approaches 5 from the right. What does this mean? It means that it approaches with numbers like 5.1, 5.2 from the right-hand side, with numbers larger. Before we even address this, I want to write a note with you. Note. A number over 0. Yes, you're going to say, but you already talked about that. A few pages ago, you made us write. Where was it? I can't find it. Of course, when I'm looking for it. Here it is. You already told us that a number that is not 0 over 0 is undefined. True. But when it comes to limits, a number over 0 has no hope. No hope for the limit to exist. Ever. No hope. What are the options? First option, negative infinity. Second option, positive infinity. Third option, what do you think?
Does not exist.
Of course. So there is absolutely no hope. Done. Now, what about 0 over 0? Because I excluded that option here. This cannot be 0. So basically, so far we're looking at these two situations, right? Any number, 5 over 0, 10 over 0, in 10 million over 0. Okay, but what about 0 over 0? This is a totally different situation. This is called indeterminate. Not undefined, indeterminate. And this has hope for the limit to exist. One more time, it says has hope. No guarantee. Ever. But has hope. This one is closed forever. Done. No hope. This one has hope. It doesn't mean that it will exist. It means it has potential. It can exist. Okay. So now I'm going to tell you a contradiction. I said several times that when we write x approaches 5 from the right, in this case, it doesn't matter, we really mean it. We mean that x does not equal 5. But now I'm going to contradict myself and say every time you're asked to calculate a limit, like in this case, x approaches 5, you have to plug in 5. And you can say, wait a minute, you just told us that x cannot equal 5. Why are we plugging in 5? We don't write it anywhere if you want. But I have to plug in 5 for at least these two reasons. So I know, is it 0 over 0? Is it 5 over 1, which is 5? Is it 15 over 1, which is 15? Is it 15 over 3, which is 5? What is it? So it can be this. I know it's no hope. It can be this, and I will learn later on in this course what to do with it. What is it? Simply 5, and I'm done. Can it be 5? Yes. So let's say I have x plus 1 divided by 2x, and x approaches 1. Yes, 1 plus 1 is 2. 2 times 1 is 2. 2 over 2, the limit is 1. So I can get a simple number. I can get something that I really don't like because there is no hope. And I can get something that has hope. I have to see what it is first. So I will have to plug it in, at least for a moment. Okay, let's plug it in. What do we get? What do we get for the numerator when we plug it in?
Six.
Good. What do we get for the denominator when we plug it in? Notice that I wrote it above the equal symbol.
0.
Good. So which of these three cases am I facing then?
No hope.
No hope. Once I identify that this is the category that this limit fits in, then I know that the answer must be guaranteed 1, 2, or 3. Only one of them. 1, 2, or 3. At this moment, I will plug in. So I know it's because it's from one side, and it's not an oscillated limit that I gave you an example a minute ago. So I'm assuming it's one of these two. So I will plug in 5.1 just to determine the sign of the infinity. So can you plug in 5.1 and give me the sign of the infinity? Because why 5.1? Because it says to the right with numbers larger than 5. My marker is drying out.
It's 6.1 over 0.
I only need the sign. I don't need any calculations. I know the answer is infinity. I only need the sign. By plugging in 5.1.
Is it positive?
That's it. That's all I wanted. Because it's coming with numbers larger than 5. This is always positive. This is always positive. So the answer of a positive must be positive. And of course, I know that x equals 5 is a VA. I have to write that down every time I get a number, an answer like that. Any questions? Any questions? Can we choose another one? Is this okay? Any questions on this? Anyone? Okay then, move on. Monica, don't touch the table, don't move the table, don't breathe. The fidgety camera will cut off. So the limit as x approaches 1 from, notice, from either side of x squared plus 2x divided by x squared minus 2x plus 1. Okay, perfect. So I'm asked to determine this limit. And where do we start?